Alright, so in this problem, I have x to the power of x is equal to 4 to the power of x plus 16. So to solve this, I want to first find the value of x. So to do that, for my solution, first start with x to the power of x is equal to 4 to the power of x plus 16. Now if I take the ln on both sides, I get ln x to the power of x is equal to ln 4 to the power of x plus 16. Now if I have something in the form ln x, a to the power of b, I can actually move this b to the front, so it's going to equal b times ln a. So in this case, for ln x to the power of x, I can move x to the front, and for ln 4 to the power of x plus 16, I can move x plus 16 to the front. So now I have x times ln x is equal to x plus 16 times ln 4. Now, if I distribute ln 4, I get x times ln x is equal to x times ln 4 plus 16 times ln 4. Now I'm going to subtract x times ln 4 on both sides. So these two cancel out. Now I have x times ln x minus x times ln 4 is equal to 16 times ln 4. Now from here, if I factor out x, I get x times ln x minus ln 4 is equal to 16 times ln 4. Now if I have something in the form ln a minus ln b, this is equal to ln a over b. So in this case, this is going to equal x times ln x over 4, which is equal to 16 times ln 4. Now, if I divide both sides by ln x over 4, I get these two cancel out. X is equal to 16 times ln 4 over ln of x over 4. So this is my answer. Alright, so in this problem, I have 19 minus 8 to the power of x is equal to 3. So the first thing I'm going to do is I'm going to subtract 19 on both sides. So now I have negative 8 to the power of x is equal to 3 minus 19. Now 3 minus 19, that's obviously negative 16, so I have negative 8 to the power of x is equal to negative 16. Now, I'm going to divide both sides by negative 1. Negative over negative is positive, so negative 8 to the power of x over negative 1 is going to equal positive 8 to the power of x, which is equal to negative 16 over negative 1, which is equal to positive 16. So now I have 8 to the power of x is equal to 16. Now, 8, this is equal to 2 to the power of 3. And 16, this is equal to 2 to the power of 4. So, now I can rewrite 8 here as 2 to the power of 3 to the power of x. And 16 I can rewrite as 2 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x, that's going to equal 2 to the power of 3 times x, which is simply equal to 2 to the power of 3x. So now I have 2 to the power of 3x is equal to 2 to the power of 4. Now, if I have something in form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 3x is equal to 4. If I divide both sides by 3, I get x is equal to 4 over 3. Alright, so in this problem, I have x to the power of x is equal to x to the power of 2. So to solve this, the first thing I'm going to do is I'm going to divide both sides by x to the power of 2. So then these two cancel out, and I'll be left with x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So x to the power of x over x to the power of 2 is going to equal x to the power of x minus 2. And now this is equal to 1. Now, I'm going to take the natural log on both sides. So now I have ln of x to the power of x minus 2 is equal to ln 1. And if I have something in the form ln a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times ln a. So in this case, I have ln x to the power of x minus 2. I can move x minus 2 to the front. So now I have x minus 2 times ln x is equal to ln 1. And if you guys already didn't know, ln 1 is simply 0. So now I have x minus 2 times ln x is equal to 0. So now this gives me two equations. I have x minus 2 is equal to 0, and I have ln x is equal to 0. So for x minus 2 equals 0, all I have to do is obviously add 2 on both sides. So I get x is equal to 2. Now for ln x equals 0, I'm going to take e to the power of both sides. So now I have e to the power of ln x is equal to e to the power of 0. Now e to the power of 0, well, anything to the power of 0 is 1, so e to the power of 0, that's equal to 1. Now, if I have something in the form e to the power of ln a, this is simply equal to a, because the e and ln cancel out. So e to the power of ln x, these two cancel out, and I'll be left with x is equal to 1. So, now to check, my original equation was x to the power of x is equal to x to the power of 2. So let's first try out 2. If x equals 2, now I have 2 to the power of 2 is equal to 2 to the power of 2. 2 to the power of 2 is 4, and 2 to the power of 2 is 4, so this is right. Now if I check 1, I have 1 to the power of 1 is equal to 1 to the power of 2. 1 to the power of 1 is 1, and 1 to the power of 2 is 1, so this is right as well. So my two solutions are right.